For this next tutorial, we're going to be working with setting variables and passing variables into functions and doing all sorts of fun things with variables. So let's start by making a variable. So right here we can make, for example, an integer variable, for example integer x, and then we use the equals, and if we look at GUI there we can see the equals when we set a variable. Set variable, there's the equals right there, so it's similar to GUI again. And in fact, this text right here is identical to vjass, except the set keyword is lowercase, not uppercase. And we'll see that in a second here. So we can go integer x equal to 5, and then down here in our actions we can set x equals 6. So notice it looks identical to the GUI, except the set keyword is lowercase. And then we can save. That's that. And for math operations, we can do plus 6, minus 6, times 6, divide by 6, plus 4, surround these in parentheses, your typical math stuff. And we could even do something like set x equal to x minus 1. And what that does is it reduces the value of x by 1. We can think of it like x is currently 5 right there. So it's 5 minus 1. We're plugging that back into x, so x is now 4. Then if we did it again, set x equal x minus 1, that's 4 minus 1, so x is now 3. So it's not all that difficult. Obviously, we can't do like set x equal to x minus 5 up here because x does not have a value yet, so can't work with it until it has an actual value. And if you remember from before, I said integer arrays, like integer array I, are automatically initialized. Scalar variables, which are non-array variables, are not automatically initialized, so they do not start with a value. And if you attempt to work with one of these, your code will crash and die, and so on. So let's try not giving it a value and printing something like call print reach here, and then we'll do something like set x equal to x minus 3, or better yet, we'll have another variable here called I. We'll do set I equal to x. And what you'll see here is that it will crash. The reach here will never get displayed. No reach here. If we give x a value like 3, it will reach there. Because now x has a value and we're reading x, so it works. Let's see. So always be careful of uninitialized variables. That's a lot of the time why code does not run or breaks or something, is because of variables that were not initialized. Anyways, moving on. How about we try creating a peasant again? So let's create a unit called u, and let's create that peasant. So with the call keyword, call, create unit, it wants the player, so let's do the player native, 0, HPA 00270, and then close parentheses. Now instead of the call keyword, we could get this value the function returns. It returns a unit there, so we can get that value out. And all we have to do is set u equal to create unit. And that will, notice no more call keyword. Now we're setting the variable to the native. So that value that the native returns is passed back into the variable. And to see if this works, let's just go ahead and try saving it, and it works. And now we can do something cool like call print get unit name, and then pass it in. It wants a unit there, unit which unit. Let's pass in the unit variable we just made, so u. And again, this returns a string, that is the unit name. And print takes a string, back up here, string message, so it all works out. Let's go ahead and save that, and that should display peasant because the unit name of a peasant is a peasant. And sure enough, right there, it's peasant. So that is how you retrieve variables values out of natives or other functions. Now let's look into strings a little bit, because we haven't really covered those that well. So for example, string hi. Oh, string hi equal to hi there. String bye equal bye. So like normal, we can do like set hi equal to 3. It has to be a string. And then strings also have one math operator they support, and that's the plus. So we can add strings together, like 3 plus bye, and that will give us 3 bye. We can even print it out, call print hi, and that'll show 3 bye. Right there. And that's all there really is to strings, I suppose. There are also things like substrings and whatnot, but we'll get into those later. So that's about all you need to know. Oh wait, nope, there's one other thing. Arrays. Setting arrays, reading arrays. So let's go back to integer array I. Now when we do something like set a variable, if it's an array, requires a little extra work. So let's try making I integer array size 1. There it is. Then we do a new action, set variable I, and then notice it wants an index. See these brackets there? That is literally the vjass equivalent. So the set keyword is lowercase, and then the rest is just vjass. So we can give it like 5, I5 equal 5. And if we convert it to custom text, right there, set I5 equal to 5. So it's virtually identical. So when we're saying an array, works just like that. Set I5 equal to 5. And there's the array set. For reading an array, let's make another variable here, integer x. Set x equal to I5. Whoop. I5. There's reading the array. So you do open bracket, the index you want to read, close back bracket. And again, these are always 8,192 indexes. Now you cannot initialize an array to some values. For example, that would not work. If we tried to save it, it would throw a syntax error. Strange syntax error, but still syntax error. In other languages, you can initialize arrays with these little curly braces here to values like 1, 3, 5, 7. So the first 4 indexes there would be 1, 3, 5, 7. Or it would create an entire array. That would be this right there. Size 4 with these values in it. But that's not possible in vjass, so we can't do it that way. To initialize an array, you would just literally have to do like set I0 equal 3, set I1 equal 5, set I2 equal 7, set I3 equal 9, and etc, etc, etc. And that concludes this part of the tutorial. Hopefully you can now work with any variable type of arrays and whatnot. You can set them to natives, you can pass them into natives, and you can just go crazy. There are other variable types that we haven't really covered, and I don't know if they're in the variable type list or not. There's the code type. That's a pretty special type, and that's not in this list. You won't find it in any list actually. The code type, you literally just type code. Oh, I should probably type that in the functions variables area. So code C or whatever name you want. Whatever. And what this does is it stores a function. So we could do, and the function also has to take nothing and return nothing. So we could use the famous do nothing function, which is my favorite and all the other vjassers' favorite. Because when a GUIer has this in their code, this is literally what it does. It does nothing. It just calls this, and as you see in here, it has nothing in it. So, utterly pointless function. And so we could do like set whatever equal the function do nothing. And that would work. Because it doesn't take anything, it doesn't return anything. Notice this function keyword out there. Whenever we're working with functions, we always need this function keyword. And then if we had something that took a function, for example, for group, that takes a function right there, code callback, we can pass it in. So we can go call for group, null, whatever, and then that would work. Alternatively, we can do function do nothing, and that's the same thing. And those are code variables. So now you know everything, most everything you need to know about variables. There's some other wacky ones still, like the bool expression type, which is like the code type but more spiffy. Triggers, timers, groups, all sorts of fun types, and there's even the region type. But we'll get into those later on.